Is here?
Yes, yes.
Yes, I think. Oh, nice. Good morning to you in Bangladesh for us this afternoon. So you are the session chair, and Professor Yan Jin from Jilin University. She is the keynote speaker of this session first, and then you will continue normal session. Along with there is another co-chair as well. So please, you can start your session.
Okay. Okay. Thank you very much. Good morning and welcome to this session number 7 of International Conference on Energy and Power. First of all, I would like to welcome all the presenters, keynote speakers, and distinguished guests. So in this session, we have 6 papers, including one keynote speech. And the keynote speech is presented by Professor Jin from Jilin University, China. So in this session, we have I have Dr. Nigran Omdong from Maya University, Thailand, as a co-chair. So this is Professor Mohammad Imdadul Haq from the Department of Mechanical Engineering, Russia University of Engineering and Technology, Bangladesh. So in this session, if everything is okay, Professor Jin, his keynote, first we will start from the keynote speech, and his her topic is wind and solar power curtailment in China, current situation and solutions. So if Professor Jin is ready, so it's everything to you. It's over to you, Professor Jin from Jilin University, China.
Yes, thank you. Thank you, Professor Hook, for the introduction. I'll talk about wind and solar power curtailment in China, current situation and solutions. First, let me introduce myself briefly. I'm from Jilin University. Jilin University is in Changchun City, Jilin Province. It's in northern eastern part of China. And I work with the College of Automotive Engineering and the State Key Laboratory of Automotive Simulation and Control. Energy is a basic human need, and the demand in China is dramatically increased in recent years. China is highly dependent on traditional energy sources such as oil, coal, and natural gas. Renewable energy plays a crucial role in climate change mitigation and adaptation in industrial nations such as China. China has witnessed the rapid development of the wind and the solar power industry. The total installed capacity reaches 293,100 and 271,000 megawatt respectively in July, much higher than the anticipated target of the Chinese government. Generally, wind and solar resources are abundant in China, but is incredibly diverse in various areas. In 2006, the National Climate Center also applied a data modeling method to assess the wind energy resource in China, concluding that 10-meter height above ground level, the technically exploitable wind energy resource is about 2,548 gigawatt, which corresponds to around 7,644 kilowatt power generation, with the assumption that the annual average number of windy hours is 3,000. we'll take a look at the phenomenon of wind and photovoltaic power curtailment in China. The figure on the right shows the year-on-year growth rate of electricity consumption. China's average rate of electricity consumption is 11.8%. Obviously, the highest electricity consumption regions are Northwest and South of China. The growth rate of electricity consumption in Northwest, Central China, East China, and the South are higher than China's average. The figure shows China wind curtailment rate from 2019 to 2021 each month. The figure above shows that the wind curtailment rate has been between 1.7% and 7.9% in the past 3 years. Obviously, the month with the highest wind curtailment rate is February. The other months with relatively high wind curtailment rates are March, April, and May. This figure shows China solar curtailment rate from 2019 to 2021 each month. The graph shows that the solar curtailment rate has been between 0.5% and 5.6% in the past 3 years. Obviously, the month with the highest wind curtailment rate is in February. The other months with relatively high wind curtailment rates are March, April, and May. Then we'll introduce the phenomenon of wind and photovoltaic power curtailment in each province. This figure shows the total wind curtailment power and the wind curtailment rate in each region. According to the figure, the provinces with the highest wind curtailment rate are Xinjiang and west of Inner Mongolia. The other provinces with relatively high wind curtailment rates are Qinghai, Shanxi, and Hebei, with low wind curtailment rates mainly in the south. Particularly, there are many places in the southern eastern area where wind curtailment rate is 0, such as Guangdong, Guangxi, Sichuan, Chongqing, and Fujian. In this figure, we'll take a look at solar power curtailment rate in each region. We can see that Qinghai and Hebei are the provinces with the highest solar curtailment rates. The other provinces with relatively high solar power curtailment rates are Xizang and western area of Inner Mongolia. Provinces with low solar power curtailment rates are mainly in southern area and the northern eastern area. Next, we'll introduce the phenomenon of wind and photovoltaic power curtailment in Jilin province. Jilin province wind energy resource. The figure shows the distribution of wind energy resources in Jilin province. The darker part of the figure represents the richer wind energy resources. Jilin province is one of the 10 million kilowatt level wind power. The installed capacity of Jilin province is 22.8 million kilowatts. Wind power has become the second largest power source in Jilin province after coal power. The maximum output power of wind appears between 12 to 14 in spring and after 19 in winter. The minimum output power of wind appears between 10 to 16 in winter and after 20 in winter. During the heating season in winter, the CHP unit and the wind power generation conflict between 2 a.m. to 5 a.m. and 19 to 23 every day. At this time, it is the period of wind power generation, and the cogeneration unit will provide a corresponding supply during this period. The heat load is also relatively large, and the minimum power generation of the unit is also relatively large. The conflict between the two caused by this prone to wind abandonment. Then I'll introduce the explorations and practices related to wind and solar power curtailment in China. In order to reduce wind and solar power curtailment, many measures have been undertaken. From the perspective of methods used to stabilize the variation characteristics of wind and solar power output, there are two mainstream solar approaches at present. One method is to store the surplus wind and the solar power in the period of low output by using energy storage devices such as energy storage batteries and pumped storage hydropower stations, and release the energy in the period of peak output in order to reduce the change amplitude in the overall output process. The other method is to form a complementary power generation system based on the complementary characteristics, natural or artificially regulated, of different power sources to achieve an overall output that is as uniform as possible. In addition to the influence of various output characteristics on this comprehensive utilization, another critical factor affecting the utilization of wind and solar power is the spatial mismatch between the power generation capacity and the power demand capacity. To establish microgrids, a large amount of distributed small-scale wind and solar power in a specific area can coordinate energy supply and demand in a complementary mode solar. With the guidance of national laws and support from related policies, China has conducted a large amount of research and established practices for multi-energy complementary microgrid projects. The mode for transmitting wind and solar power directly into the local power grid using the peak load regulation capacity and the frequency modulation capacity of a local grid to reduce the uncertainty of wind and solar power, as well as achieving new energy consumption, has become the most mainstream mode of new energy utilization. This is a power grid peak shaving operation consumption mode. To improve the peak load regulation ability, of a power grid, large amounts of large-scale peak load regulation power sources, including reservoir hydropower stations, pumped storage stations, and peak load regulation thermal plants are often installed on the grid side. Energy storage devices are used to reduce the uncertainty of wind and solar power. Storing energy when wind and solar power is abundant and releasing energy if wind and solar power is insufficient. Achieving multi-energy complementation and consumption by forming a wind PV storage integrated emergency system has become a feasible method. The figure shows an energy storage project. This project is located in Zhejiang, one of the 8 national 10 gigawatt level wind power basins and sources of large amount of solar energy. The project consists of 500 megawatt wind power and 100 megawatt solar power and 70 megawatt storage capacities. A pumped storage hydropower system can store power by using surplus power to pump water to an upper reservoir and generate power by releasing water in the peak load demand period. Thus, PSHP is an excellent peak shaving power source. Using PSHP's peak load regulation capacity to transform wind and PV power into hydropower and then form a stable output process to a power grid is a typical wind PV storage complementation mode. Before new energy is transmitted and connected to the grid, the wind and solar power needs to be supplemented with other local power generating forms with peak load regulation capacity and then transmitted for grid connection. This process avoids the impacts of the uncertainty of wind and PV power outputs on the receiving end grid. So it is an effective method for China to solve the problem of large scale and centralized grid connections of new energy. A combined wind PV thermal power consumption mode will play an essential role in utilizing clean energy in China. The figure shows the wind PV thermal power transmission project in Hami, China. Hami is one of the national clean energy bases with the capacity at the 10 gigawatt level to achieve clean energy consumption, known as the Tianzhong DC project, has been built. The 3 north area of China, northern eastern China, northern China, and the northern western China has abundant wind and solar energy resources and is also rich in coal resources. The wind PV thermal multi-energy complementation consumption mode can effectively utilize the rich coal resources in the 3 north area of China. After stabilizing the intermittent and unstable output processes of wind and solar energy using hydropower resources in the region, clean power can be consumed in dried grid connection or transmission after combination. This is known as the wind PV hydropower complementary consumption mode. Complementary clean energy bases along the Yalong River in Sichuan province. The Yalong River in Sichuan, with an overall length of 1,571 kilometers and a natural drop of 3,830 meters. Currently, 21 hydropower stations with a total installed capacity of about 30,000 megawatt and multi-year average power generation of about 150,000 gigawatt hour have been planned or built along the mainstream. Then let's take a look at 3 types of research to reduce wind and solar power curtailment. The first one is CCHP of large capacity districts based on Homer and multi-objective particle swarm optimization. Here, CCHP is a combined cool heat pump system. This graph shows the schematic diagram of CCHP system. The CCHP system has the following advantages. The system priorities renewable energy, which can achieve the purpose of energy saving, and the gas turbine can combine heat and the electricity. And the third one is that the excess energy of the system can be stored in the battery or sold to the grid. The central core of multi-objective particle swarm optimization is the maintenance of external files, allowing the next generation of particles to have a variety of global best choices, enhancing the diversity of solutions in external files and making more non-inferior solutions evenly distributed on the target space. The primary process of this research is to set the target area and calculate the installed capacity of wind turbines and solar power through the Homer platform. These figures shows the optimal solution operation diagram of the typical load day in January and winter. The second solution is that a joint research algorithm for every scheduling of the CCHP system. This research proposes a joint search algorithm based on particle swarm optimization algorithm and Cuckoo optimization algorithm for every management of CCHP system. The third one is an introduction to the construction of the AACES system. Advanced adiabatic compressed air energy storage system is an emerged compressed air energy storage power station system in the world. It has relatively higher system efficiency than compressed air energy storage system. The construction of this system in the research is based on the structural model of the 1.5 megawatt demonstration power station of the Chinese Academy of Science. This system includes four-stage compression and four-stage expansion using interstage cooling and interstage heating. This work has reviewed the renewable energy curtailment experience across several provinces in China to illuminate the breadth of experience and methods that have been effectively employed to manage curtailment levels. Based on the China's experience and our research, the following suggestions are given for the trend. First, there is a potential to combine investment in renewable energy with power to gas, converting electricity to hydrogen via electrolysis for an alternative revenue. And focusing plays a central role in minimizing this uncertainty on operational time scales from real time to a few days ahead. Both wind speed and solar irradiance exhibit spatial temporal correlation as a result of their dependence on large-scale meteorological phenomena. Thank you to the conference conveners and all participants for making this an interesting and engaging event, and to our team for invaluable conversations. This work was supported by Royal Academy of Engineering of UK under UK-China Industry Academia Partnership Program scheme, and supported by National Key R&D Program of China. Thanks to you all. Thank you.
Okay, thank you very much for your nice presentation, Professor Ying. So now we have 3 more minutes for discussion. So dear participant, distinguished guest, so time is yours. If you have any question, comment, or concern, please ask Professor Ying.
Can I ask?
Of course.
Yes.
Please.
Well, it was an excellent presentation, Professor. I want to know what is the potential of this hydrogen as a fuel in the visions and policies for China in near future.
Sorry?
I want to know the potential of hydrogen as a fuel for China hydrogen in near future. Yes.
Yes. China is now do many researches on hydrogen. It's ongoing.
Is there any commercial already, or it is in the research state?
Yes, I think in some area such as automobile and so on, they are doing some research, and the government are doing many these
investments.
Yes, investments. Yes.
And do you consider hydrogen will eliminate many of such renewable initiatives? Hydrogen prospect.
I think hydrogen and many other renewable energies will
dominate.
Yeah. Which one will dominate? I think maybe solar power and wind power will be dominant in long term.
Okay. Thank you very much.
Thank you.
Okay, thank you. So we have 1 more minute. So if any one question from the participant.
Then I will ask one more. If tidal, what is the prospect of tidal energy? Because lot of oceans are there. So tidal energy utilization, China has some policy.
Sorry, what energy?
Tidal energy,
Tidal,
waves, tidal energy from oceanic waves.
Tidal from ocean.
A tidal, T-I-D-A, tidal.
E-I-D-A.
That means tidal energy. That is from waves.
From waves.
Waves.
Yes. Also, there are some scholars are doing research on tide energy, mainly on eastern region.
Okay then. Thank you.
Thank you.
Okay, thank you, Professor Ingai, for your nice and wonderful presentation. If still you have question, please you can contact with her anytime using her email. Okay, thank you. We can move to the next presenter. So the next presenter is Dr. Kitty Fong Yaovaza. I think she is here. So you want to present directly, or we should play the video? Dr. Kitty Fong Yaovaza, you want to present here?
Hello, good morning. Do you hear the sound?
Yes. So you want to present, or we should play the video?
So I can present again.
Okay. Our next presentation is from Dr. Kitipong Yaovaza, and the title is Reduction of Fine Particulate Matter PM2.5 emission from light duty diesel vehicle idling using compressed natural gas in dual fuel mode. So please, Dr. Kitipong Yaovaza, please continue.
Thank you very much, everyone. I am Kitipong from Thailand. I'm working on control system. I present this paper. This is about the alternative field that I worked for many years. The name is about reduction of the PM2.5 emission. I think everyone know about PM2.5 emission, and that has a source from different sources, but one of them is from the vehicle. So we can reduce some vehicle from the diesel engine by using the natural gas in the dual fuel mode. So the outline of the presentation here is about the background of the control system that I'm working, and the PM2.5 emission, and the objective to reduce the PM2.5 from a diesel vehicle. And we use the dual fuel engine and control technique, and I show the results. So this is the introduction. So I work on the control system for robotics and mechanical system, and also implement it on the automotive control for reduce the emission and also improve the performance. One of the important thing is to use alternative fuel to reduce the diesel usage And the benefit is to reduce the PM2.5. We know that PM2.5 can cause a health problem, can make a disease, cancer, and we have the air quality standard level for PM2.5 is about 65 microgram per cubic meters. And in many countries, include in Thailand, Bangkok, Chiang Mai, we have a lot of PM2.5 emission exceeds standard level. We can reduce it. They have a few techniques to reduce it. In China, we can use air purification. This is a big tower which can reduce a little bit PM2.5. That is still a huge problem that we have to solve. Then I think we have to eliminate it from the source. One of them is from the traffic. The PM2.5, we can measure it from a different technique. We can use the satellite to reduce the emission, to detect the emission. This have a ROSO optical depth camera, but on the ground we have a sensor like a gravimetry sensor, beta ray absorption, oscillating microbalance, and light scattering technique. The first three equipments is quite expensive. It costs about $20,000 and more. So the new techniques have been developed and can be used to capture the emission data. So we interested in this sensor. It was nowadays in the market, everyone can purchase this and use this to measure the PM2.5. And we have calibration data that confirm the accuracy and precision of this data from a lot of research and tests. So we found a lot of information that show the calibration accuracy. So this is the test between the light scattering sensor with the older technique sensor, which show the trend of measuring data. And it also depends on some relative humidities, dew point, temperature, wind speed. And also the right-hand side is FRM. This is standard measurements as a reference or equivalent methods. So in the low PM2.5, we have high accuracy and some variation at the high level. So it will affect some variations. And we know that the D cell provide a lot of PM2.5 emissions, which directly cause a health problem. From the previous research, we found that it's about 100 times PM2.5 more than the gas engine, which is used in natural gas. So we know the natural gas could be more good environmental, and we can replace it. But actually there is a lot of diesel vehicle like many millions a vehicle. We cannot replace it with an electrical vehicle. It also depends on energy supply. So we have to think about how to reduce this. We can use a dedicated and dual fuel engine. Dual fuel have a less conversion price, and it can convert to dual fuel mode, which can have a good efficiency, but the challenge is to control the combustion. And we have to have a good control system to control the combustion. And we know if we can control the combustion well, we can get a good results. And we can implement the control technique to alter system. Like there's a lot of combustions. Like I think a rocket is still use a combustion. We can control it to have less combustion knock and less hot combustion and get also good emission results. We did some research on the control techniques to reduce the emissions. So this is a research we done implemented on a vehicle, and we control a feedback control to control the fuel pressure and idle speed control. And then we set up the experimental setup. We can reduce the emission from the tailpipe. We install the sensor, and we have a PM 2.5 background. It's about 30. This is the vehicle that we tested. And the results, we can reduce the PM 2.5 when we use more natural gas. It can reduce up to 10 times, up to 100 times. 10 times. We can use a natural gas about 80 to 90%. When we increase the millisecond, this means the duration of the gas injection, the natural gas injection. So we have to control the combustion by control the diesel injection too. And they have a slightly effect from the diesel injection. We know that, we all know that it's effective combustion. So we test with the PM 2.5 output, the relative from the injection of the diesel. And we also test the transition. So we can see the behavior when we switch between diesel mode to a dual fuel mode. So what we found is about 45 seconds, 50 seconds to have the steady of the emission output. So it could say the settling time would be about 50 seconds. And there are some delay time. This depends on the field that we use. It could be up to 8 milliseconds. If you see how when we switch the dual fuel from the diesel, it still have no effect of the emission until X seconds. So the conclusion, we developed the dual fuel engine. We focus on engine idling because when we have a high traffic and the car is parking, is stopped and is idling, it will cause emission, especially to rider, pedestrians, and residents. And also we use the emission sensor to detect it. We can test the modified dual fuel engine with the fully controlled to reduce about 10 times of PM 2.5. And we found the proper injection, start of injection, and we found the transition from the diesel from dual fuel that could affect to PM 2.5 about up to 50 seconds. So this is about the presentation. Thank you very much for listening. The presentation.
Thank you, Dr. Kittipong Yolfaza, for your nice presentation. So we have 2 minutes. So I welcome any comment or question for this presentation. Okay, if no, I have one simple question, Dr. Kitipong. So you have introduced CNG for improving PM emission level, right? So how you can improve the performance of the engine?
It depends on the injection strategy, the ratio of the natural gas that we put, and one is the combustion strategy, and then is the control strategy. If we can control its parameters well, we can have a good and precise output from the combustion. So it depends on the good calibration and the good control to handle all the variation, to handle all disturbance. We normally call some robustness from all effects. Sometimes we have a different fuel properties, then we have to control, and moreover we can attach more sensors to detect the output. So thank you.
Okay, thank you very much for your nice presentation. So we should move to the next presenter. So Dr. Nigran Homdong, please continue. Is it okay with you?
Yeah, sorry, may I go ahead, please?
Dr. Nigran Homdong.
No. Please invite Samuel Amo.
That's right. May I go ahead?
Next, please.
Yeah.
Okay, our next presenter is Mr. Samuel Auku from Robert Gordon University, UK. And the title of his presentation is Enhancing the Appearance of Building Integrated Photovoltaics Through the Application of Traditional Symbols, using Ghanaian Adinkra symbols as case study. So now I'd like to request Mr. Samuel to continue your presentation.
Thank you very much. It's an amazing opportunity. My name is Samuel Amo Ewuku, and I am from the Robert Gordon University in Scotland, United Kingdom. I'm excited to share a portion of my PhD dissertation, which is about enhancing the appearance of building integrated photovoltaics, BIPVs for short, through the application of traditional symbols, using Ghanaian Adinkra symbols as case study. So the major highlights for this presentation are, I'll touch on the meaning of building integrated photovoltaics. I'll touch on the aesthetics of BIPVs. I'll consider the drivers of BIPV adoption. We'll look at symbolism and buildings. We'll look at Ghanaian Adinkra symbols and their influence in BIPV adoption, and then the method, and then some basic findings from my study. Blending a formal background in design and energy, this topic is quite fascinating because it touches on the aesthetics of the beauty of energy or photovoltaics. So building integrated photovoltaics, BIPV for short, basically refers to the use of solar PVs to replace conventional building materials, such as roof, facade, or windows. So in this instance, the solar PV forms part of the building envelope. At the end of the day, we don't see a separation or a differentiation between the building material or the PV. In other words, the PV forms part of the building envelope. So it replaces the building material. And then when we talk about aesthetics, aesthetics is basically the art of beauty. And it's a philosophical concept that examines beauty or taste. So basically, these are the two key terms I'll be using throughout my presentation. The idea of BIPV is, of course, to introduce a more efficient way of utilizing solar photovoltaics to produce electricity in buildings while considering architectural appeal. Considering the recent advancements, the recent repercussions of climate change, hence the need for net zero energy buildings, many architects, many industry players, many governments are moving from just basic design to efficient buildings, energy efficient buildings. And when we talk about energy efficient buildings, one of the most profound technologies that have come are building integrated photovoltaics. Because at the end of the day, you are blending solar PVs into your building such that they form part of the envelope. There are two cardinal or key ways of applying solar PVs. The known building applied photovoltaics. Building applied photovoltaics is basically the conventional mode of application we know, where we have these PVs being put on top of your building when you are done. So you finish building and then you just put, let's say, about 5 panels, 5 PV panels, 10 PV panels, depending on your expected capacity on the building roof, and that's it. But with building integrated photovoltaics, the main difference here is the way of design and the integration. So with BAPVs, it's an add-on. At the end of the day, you finish building, and then you add the PVs to your building. But with BIPVs, you have the PVs forming part of the building envelope. So one advantage is BIPVs are architecturally clean, and they are, of course, very attractive, and they offset the cost of roofing, facade, or glazing material. So for instance, if you are spending X amount of money on roofing sheet, now you are no more buying the roofing sheets because you are using solar PVs to replace your roofing sheet entirely. So at the end of the day, it's like killing 2 birds with 1 stone. So at the end of the day, instead of buying or paying for roofing sheets, you are no more paying for roofing sheets, but you are buying solar PVs that are able to replace your roofing sheet. You have energy at the end of the day, plus you have your roofing sheets at the end of the day. So these are scenarios. On my right, you see building integrated photovoltaics, which are mostly applied on the roof. They could form part of the envelope on the facade. And then on my left, you see building applied photovoltaics on the roof. Mostly the difference is clear. And I'm sure if we are asked to choose, most people will go for building integrated photovoltaics. Why? Because of the obvious. It is carefully integrated. It looks aesthetically pleasant. It is more appealing. It is beautiful. But on the left, it looks a bit haphazard. It looks a bit disoriented, unorganized. So in Ghana, in the context of Ghana, these are some of the current PV applications. On my right, you see a solar PV being installed on the roof. In Ghana, BIPVs are virtually non-existent. People don't know about building integrated photovoltaics. We only know about conventional solar PV applications. So these are the basic ways we apply solar PVs in Ghana. If you look at this, is a typical rural building in Ghana where we have, after constructing your mud house with huts, raffia on the roof, you have these solar PVs being spreaded for basic electrification in a rural area, typical rural setting. And in the contemporary or the modern world, you find these PVs being incorporated into the building envelope such that they form part of the building, like we see in these figures, forming part of the roof, of the facades, which are beautifully displayed. So the big question here will be, why has the adoption of BIPV been relatively slow? People will talk about the high costs because, of course, these are expensive technologies. They are still not that cheap where many people can easily afford. But if you do the mathematics and the comparative analysis, you would realize that these BIPVs have some competitive advantage, even over other PV applications. And then we can talk about the technical limitations, where we look at, are there a lot of technicians or people who have mastered a holistic way of applying these PVs into building envelopes such that we overcome the technical limitations? Are there technicians, are there people, in case there's a breakdown in the roof, will there be a technician who can easily come over and fix it, just like you would have a carpenter fix your roof? So we ask ourselves all these potential limitations, and then we can talk about the aesthetics. Aesthetics is also a major limitation, because if you are looking at a material that will potentially replace a conventional building material, then it means that that material must be beautiful enough to appeal to architects, to appeal to potential homeowners, to appeal to potential adopters. For instance, if you go to the market to buy, let's say, a wall tiles for your facade, I'm sure you all will look out for a particular color, particular texture, particular shape that is quite beautiful or appealing. Imagine you go to the market and you see PVs being displayed in their monocrystalline or monopolycrystalline black and blue colors, and these are the only colors we have. Definitely, I'm sure most of you will feel like, okay, these are the conventional, but I'm not ready for it, I'm not interested, because they are not aesthetically pleasing or they are not aesthetically appealing. So it means that aesthetics is a matter of urgency when it comes to BIPVs. One of the major quotes some experts have propounded is that the leading barrier to the widespread adoption of BIPV is the look of the product. While solar companies strive for maximum efficiency, builders want product to be functional and aesthetically appealing. So what is the new addition? What is this research aiming to do? We are introducing symbolism. Symbolism is basically the use of abstract symbols to represent an idea or to portray an idea. In Ghana, these are popular traditional symbols that mean a lot to the Ghanaian people. Adinkra symbols are powerful visual symbols that convey deep proverbial messages. They show wisdom, they demonstrate philosophical thoughts, ideas, or aspects of life or the environment. So wherever you see these symbols or these symbols are displayed in Ghana, then you'd realize that people have this emotional or traditional or cultural attachment to it. I don't know if any one of you have ever been to Ghana, but you'd realize that the Ghanaian people are very cultural or traditional. In other words, we have a strong taste or a strong attachment for culture. So these symbols have been displayed mostly on our cloth, on our fabric. They've been used as emblems, as logos on our buildings, and they all have meanings. For example, this very first one is called the Dinkahine. It's a symbol of greatness, charisma, and leadership. The Akofina is a symbol of courage, valor, and heroism. The Jinyame symbol is a symbol of supremacy of God. And then the Nchinchim is a symbol of initiative, dynamism, and versatility. So all these symbols appeal and mean a lot to the Ghanaian people. This is a popular hotel in Ghana called the Golden Tulip Hotel. As you can clearly see, these symbols have been demonstrated on the walls. They've been used for the beautification of the walls, and they appeal to the Ghanaian people a lot. So the big question, another big question, hypothetical question here is, will incorporating some of these visual symbols to the final outlook of BIPVs influence its adoption in Ghana? So I conducted a simple architectural methodology called architectural visualization, where I used graphic design symbols to illustrate traditional buildings. And then I embossed some of these symbols just to give a visual effect of how these symbols will appear, or the outlook. And then we ended up with these very basic look. And then this is a classical example of a modest home or a rich man's house in Ghana, where we have some of these symbols being displayed on the facade. So I did a we did a simple market survey to analyze people's interest or how people will react to these symbols. And it appears that the majority of people went for the symbols. They said the symbols are nice and they'll be happy to incorporate the symbols if they are embossed on BIPVs. We had about 65% of the market indicating their interest in the symbols. What are the implications? As observed, majority of the respondents, 65%, indicated that adding these symbols to solar design can influence the decision to adopt BIPVs. The remaining 35 were not sure. This gave an indication that incorporating traditional symbols into BIPVs when applying BIPVs may influence their adoption. This will help current and prospective homeowners to have a local feel of this relatively new technology, as these symbols are already familiar to them. These symbols can be general. There could be Japanese symbols, there could be Chinese symbols, there could be Scottish symbols, depending on where you are. So I believe that these symbols will can go a long way to influence the adoption of building integrated photovoltaics across board. I'll be happy to take your questions now. Thank you so much to the organizers and to the government of Ghana through the Scholarship Secretariat for sponsoring this study. Thank you very much.
Okay, thank you very much, Mr. Samuel, for presenting interesting research topic. So we have maybe we can take one questions from the participant.
Yeah.
Okay.
Yes, my question is a very nice presentation. My question is that these symbols, whether going for some industrial standardization internationally or not?
Yes, these symbols are yet to undergo the industrial standardization, but within the Ghanaian context, they've been applied on various substrates. So they are generally known by the Ghanaian people. But in terms of these symbols being used on solar PVs, this is the first of its kind. So this makes this research quite novel. And we are hoping to explore the standards that could potentially allow this to be traded across board.
Thank you. Thank you very much.
Welcome.
Okay, thank you, Mr. Samuel. So we should move to the next presenter.
Can you hear my voice clearly?
Okay, so our next presenter is Ms. Yang-Ling Chen from Zhejiang University, China. And her research topic is experimental study on the effects of the wall weightabilities on the fuel film characteristics. So I'd like to welcome Ms. Yang-Ling Chen to continue your presentation.
Hello, everyone. My name is Yang-Ling Chen from Zhejiang University in China. I'm very honored to attend the third International Conference on Energy and Power. The topic of my presentation is experimental study on the effects of the wall weightabilities on the fuel film characteristics. My presentation will be divided into the following 4 parts: background, experimental materials and methods, results and discussions, and conclusions. Now, let's look at the background. With the increase in the number of vehicles, energy shortages and environmental pollution problems have become increasingly serious. The new combustion modes are often used to improve energy performance and reduce emissions. Premixed compression ignition modes often use the early injection, the multiple injections, and the high pressure injection to improve atomization quality. Due to the low temperature and gas density at the early injection timing, the wall weighting is inevitable. Therefore, it's particularly important to explore the interactions between the fuel and the walls and conduct in-depth research on the formation and evaporation of fuel films. To reduce the hazards of fuel spray wall impingement, many scholars have carried out a series of research work on the optimization of fuel injection parameters, the design of combustion chamber structure, and the change of fuel properties. To further improve the controllability and stability of the advanced combustion modes, the wettability of the surface can be improved in combination with the bionic theory, aiming at the problem of wetting in internal combustion energies. The leaf method is used to study the spatial and simple distributions of fuel films after unbuttoned walls with special wettabilities and different wall temperature conditions. Now, I will give a simple introduction to the experimental materials and methods. Unbuttoned is selected as the test fuel. Rhodanine B is added as a well-characterized fluorescence tracer to generate adequate leaf signal. The microscopic morphologies of the metal surface are measured and recorded using the scanning electron microscope. The variations of the contact angles of the unbuttoned droplets on the test metal surface with time are recorded with the contact angle measurement. The morphological developments and the evaporation process of the fuel films after impacting the surface are recorded with a leaf test plate form. The alloy is selected as the material of the test surface. The surface microstructures are reconstructed through laser etching, chemical etching, and the surface-free energy modification. The development processes of the fuel films after impacting the surface at 5 different wall temperatures are investigated. According to Lambert-Beer law, the fuel film thickness and its fluorescence intensity can be calculated use the equation 1. In this experiment, equation 1 can be simplified to equation 2. That is, the fluorescence intensity is proportional to the fuel thickness. To obtain the relationship between the fuel film thickness and the fluorescence intensity, different fuel film thicknesses are calibrated. Third, results and discussion. From a macro perspective, the octagonal grid structure is seen on the laser-etched surface, and the labyrinth structure is observed on the chemically etched surface. From a micro perspective, the micro-scaled convex domes and grooves and the nano-scaled protrusions are oddly formed on the laser-etched surface. The rectangular shaped staggered covered burst piece and needle-like structures are formed on the chemically etched surface. The development process of the fuel films after impacting the different surface are investigated. It can be seen in figure that at the lower wall temperatures, the shape of spreading area of the fuel films maintains an elliptical shape, and the fuel films show a heel-pack-like. When the wall temperature is 398 kelvins, there are bubbles between the fuel films and the wall surface. With a further increase of wall temperature to 423 kelvins, the surface Sn and the surface Ln is observed that a large number of bubbles are rapidly generated between the fuel films and the wall surface. In the experiments, it's also observed that a vapor film is formed between the fuel film and the surface CF. To analyze the effects of the wall wettability and temperature on the film characteristic, the areas average thickness and the mean square areas of fuel films after impacting the 3 surface at the lower wall temperatures are analyzed. It can be seen from the figure that in the process of increasing the spreading areas, the friction between the fuel films and the wall surface and the air resistance make the growth rate of the spreading areas gradually slow down. The results indicate that the stronger the lithophilicity of the surface, the larger the maximum separating area of the field films. When the wall temperature is 398 kelvins, there are more small bubbles on the lithophilic surface Rn. The upward movement of small bubbles in the field film promotes the evaporation. However, on the oleophobic surface CF, small bubbles are easy to gather, and the heat transfer rate is reduced, which is the main reason that affects the evaporation rate of the field film. As shown in the figure, at a lower surface temperature, the average thickness of the field films on the three surfaces decreases continuously over the time. The average thickness on the surface Rn is the smallest, and on the surface CF is the largest among all the three surfaces. It implies that as the well lithophilicity increases, the average thickness of the field film decreases. As the wall temperatures increase, due to the field film evaporation rates increase, the average thickness of the field films on the three surfaces decreases compared to the lower wall temperatures. At the same time, the wall temperature has a great effect on the average thickness of the film than the wall wettability. It can be seen from figure that due to the continuous evaporation of an butanol, the field films on the three surfaces with different wettabilities become thinner. The overall thickness becomes smaller. The maximum thickness becomes smaller, and the field film distributions are more uniform. As the surface lithophilicity increases, the field film thickness becomes more uniform. In addition, as the well temperature rises from 323 kelvins to 398 kelvins, the spreading rates and the evaporation rates of the field films on the three surfaces increase. Finally, this part is the conclusion. The previous part has been introduced in detail, so I won't repeat it here. That's all. Thank you for your attention. Thank you.
Okay, thank you, Ms. Yanling Chen, for your nice presentation. Now we have some time for discussion. So please, if you have any question or comment, please ask. Any question from the audience?
I think it was a nice presentation. What is the future prospect of this research?
Aiming at the wall wetting in the international combustion energies to active control the wall wetting, the wall wettabilities, the wall of wettabilities is fabricated to reduce the emissions of soot particles and burned hydrocarbon.
Okay, thank you very much.
Thank you.
Okay, thank you, Ms. Yanling Chen, for your nice presentation. So next, I would like to welcome Ms. Tasitha Samarasinghe from Monash University, Malaysia campus. And her topic of presentation is photocatalytic activity of carbon nanotube, zinc oxide nanocomposite for solar energy-based water treatment, and photoelectrochemical water splitting.
Can you hear me?
Okay. Now time is yours.
Yeah, all good.
Please
Thank
continue.
you. Hello, everyone. I'm Lasitya Vishoda Samarasinghe, and I'll be presenting my final year research project that was carried out as part of my undergraduate studies at Monash University, Malaysia. And it's about the photocatalytic activity of carbon nanotube zinc oxide nanocomposite for solar energy-based water treatment and photoelectrochemical water splitting. So to begin with, I've divided the presentation into 5 parts. I'll be introducing the topic and going through some research background first, followed by the method that I've followed during the research. Then I'll go through the results, highlights of findings, and the recommendations for future study. So when light is shown on a semiconductor with photon energy greater than or equal to the band gap energy of the semiconductor, it will cause excitation of electrons from the valence band to the conduction band, and that will produce excited state conduction band electrons and valence band holes. So the valence band holes will react with hydroxide and water to produce hydroxyl radicals, and the electrons will react with oxygen to produce superoxide radical anions and hydrogen peroxide. These superoxide radical anions and hydrogen peroxide will react to produce hydroxyl radicals as well. And these hydroxyl radicals that are produced, they are highly oxidizing, and they will react with any organic molecules present and degrade them. So that's what basically happens in the degradation of organic dyes. And in hydrogen generation, the holes will take part in the oxygen evolution reaction, producing oxygen, and the electrons will flow to the counter electrode through the external circuit and take part in the hydrogen evolution reaction, generating hydrogen. So for this research, I've chosen zinc oxide as the semiconducting material due to its good photocatalytic activity, low cost, and non-toxicity. However, the main drawback of this photocatalysis process is the high recombination rate of the photogenerated electron-hole pairs. So that will dissipate energy in the form of heat. So to reduce this recombination, what we can do is use a composite of the photoabsorbing material along with a charge carrier transporting material. So I've used carbon nanotubes in this study due to its hollow nature. It provides a large specific area. And other than that, these carbon nanotubes act as adsorbents themselves, which means that they will degrade any organic molecules present, so which will further improve the dye degradation results. Moving on to the synthesis of the composites. So in this study, I've prepared 2 composites with distinct morphologies. I've used FTO as the primary substrate, and to prepare the layer by layer sample of zinc oxide CNT nanocomposite, I've deposited 3 layers of acid-treated CNT on top of cleaned FTO, followed by 3 layers of zinc oxide seed solution spin-coated on top of the CNT. And then I've annealed it and grown it to obtain the zinc oxide nanorods. That's how the layer by layer sample was prepared. And to prepare the mixed sample, I've spin coated 3 layers of acid treated CNT zinc oxide on top of cleaned FTO. And then it was annealed and grown as well to obtain the nanorods. And both these samples were washed with DI water and dried before they were used for testing. So to carry out the dye degradation test, I've used Congo red dye, which is a light red color dye. And all these samples were tested on the AM 1.5G filter and UV filter. And they were left in darkness for around 1 hour to make sure that they reached adsorption-desorption equilibrium between the dye molecules and the nanocomposites. So after that hour, the UV spectrophotometer was used to obtain the absorbance readings every 30 minutes for the next 3 hours. Moving on to the photoelectrochemical measurements, I've used a 3-electrode assembly connected to the gamma interface. Again, the AM 1.5G filters and UV filters were used to obtain the results, and linear sweep voltammetry and chronoamperimetry results were recorded here. So this slide shows the experimental setup I used. Figure A at the top here shows the dye degradation setup, and figure B shows the PEC setup that was used. Moving on to the characterization test. I've done 3 characterization tests here: FESCM, XRD, and optical characterization. So from the FESCM micrographs that were obtained, it could be seen that inclusion of CNT reduced the diameter of the zinc oxide nanorods. As you can see, these are the readings that were obtained for the mixed and layer compared to the PO1. And also it could be seen that the nanorod distribution was irregular in the mixed sample compared to the other ones. So this slide shows this is the PO zinc oxide nanorods, this is the PO CNT, this is the mixed one, and the layer by layer sample. Moving on to the XRD results, it could be seen that PO zinc oxide nanorods and the layer by layer sample had peaks corresponding to the 002 plane of the hexagonal word side structure of zinc oxide. So the presence of this peak shows that the nanorods are aligned along the vertical z-axis. And there were other major peaks corresponding to the hexagonal word side structure of zinc oxide as well in both the mixed and the layer by layer sample. Moving on to the absorption spectrum. It can be seen that the absorption edge of pure zinc oxide is around 368 nanometers, which corresponds to a band gap energy of 3.37 electron volts. And mixed as well as the layer by layer samples had similar band absorption edges as well. So all these 3 samples exhibit absorption in the UV region. So based on the results from the absorption spectrum, we can expect a good photocatalytic activity under UV illumination. So this slide shows the dye degradation results that I obtained. And it can be seen that the layer by layer sample had the highest degradation, followed by the PO zinc oxide nanorods, the mixed sample, and the PO CNT sample. So these samples followed a similar trend under AM 1.5G filter as well, although under UV filter, it showed 1.6 times higher degradation compared to the degradation under AM 1.5G. And it can be seen that the layer by layer sample has the highest degradation under both UV and AM 1.5G filters. Moving on to the PEC results. So linear sweep voltammetry was carried out first to identify the photocurrent responses of the electrodes to different applied potentials. And based on those results obtained, it could be seen that there was a significant difference between the dark and light conditions at plus 0.5 volts. Because of that, chronoamperometry results were measured at an applied potential of plus 0.5 volts. So this slide shows the chronoamperometry results that I obtained. Again, we can see that the layer by layer sample showed the highest photocurrent density under both UV, which is this one, and AM 1.5G filter, followed by the PO zinc oxide nanorods, mixed sample, and finally the CNT sample. Although, again, the samples performed well under UV compared to AM 1.5G filter, and the results were almost twice under UV compared to AM 1.5G filter. Moving on to the highlights of findings. So incorporation of CNT improved the photocatalytic as well as the photoelectrochemical activity of the layer by layer sample as expected. And that is due to the fast separation and transportation of the photogenerated electrons, reducing the recombination, the smaller particle size of the nanorods, which leads to a larger surface area, and the presence of nanorods along the z-axis. However, inclusion of CNT did not increase the photocatalytic or the photoelectrochemical activity in the mixed sample, and this can be attributed to the fewer nanorods present in the mixed sample, the irregular distribution, and also the nanorods not being aligned along the vertical z-axis. Also, it could be seen that all the samples showed higher results on the UV filter compared to AM 1.5G filter, and ranking for both dye degradation and PEC followed the same trend, with the layer by layer sample showing the highest results, followed by the PO zinc oxide nanorods, the mixed sample, and finally the PO CNT. So for future recommendations, because zinc oxide is thermally stable, this degradation and PEC could be carried out under different temperatures and pH values, and the optimum parameters could be obtained. And this CNT zinc oxide could be incorporated on polymeric membranes such as PVDF, and their photocatalytic activity can be tested out. So I would like to thank Dr. Chiang for her valuable guidance throughout my research project and Monash University, Malaysia. So that brings me to the end of my presentation. Thank you very much for your attention.
Thank you very much, Ms. Lasita, for your nice and wonderful presentation. Now I will welcome any question or comment for this presentation. Any question and comment? Any question from the audience? Okay, I have one small question, Ms. Lasita.
Yes.
So, how was the comparative study of photocatalytic activity of carbon nanotube and zinc oxide nanocomposite?
Yeah.
Carbon nanotube over zinc oxide nanocomposite. Will you explain it?
Sorry, could you please repeat the question?
About the photocatalytic activity of carbon nanotube.
So what I wanted to study here is the difference in the two morphologies. So compared, from previous literature, it shows that incorporating CNT will increase the photocatalytic activity. But based on the research that I carried out, I could only see that the layer by layer samples photocatalytic activity got improved, but not the mixed samples photocatalytic activity.
Okay, thank you. Okay, thank you very much. So we should move on to the next presenter. Our next and final presentation on energy security evaluation through solid waste management in Dhaka city, Bangladesh. So it will be presented by Dr. Altaf Hussain from Military Institute of Science and Technology, Bangladesh.
I want to do a little bit of correction because it was Professor Altaf Hussain and also the principal author.
Okay, is there any co-author of that?
So I'll be presenting on their behalf.
Oh, okay, thank you, Professor Firoz Alam. Please continue.
Okay, good morning to you all, and also good afternoon, depending on where you are, or good evening as well. The topic is energy security evaluation through solid waste management in Dhaka city, Bangladesh. Authors are Shamim Ahmed from National Defense College, Bangladesh, and Altaf Hussain also from the defense area, Military Institute of Science and Technology, and myself at the end from RMIT University, Australia. Unfortunately, Shamim Ahmed and also Altaf Hussain, they could not make the time during this time to present the paper because they are out of the stations and they have no reliable connection. So they requested me to present the paper on their behalf. So let's go. As you see in the beginning, in the title, that there is a word called energy security. So let's go to a little bit clarify what is energy security, and then we can move on. The energy security is an adequate supply of energy.
We are getting some background noise. Kindly switch off the others apart from the speaker. Otherwise, it will be a little bit disturbing. Please.
So I'm giving you a little bit of highlight about energy security. The energy security is an adequate supply of energy across electricity, gas, and liquid fuel. At an affordable market price. Now here I draw your attention, it is not affordable price, because affordable may be affordable for you, but other people not. Or maybe it is affordable for you, but it is not a market value. Nobody will sell to you. So that's why it is a affordable market price. Responsive to the demands of decarbonization economy and measured disruption. The most important part is the measured disruption. So this is energy security. Energy security, it is not only oil and gas, it is electricity, gas, liquid fuel, and also other energy, which is really can supplement this particular issue. Energy security means the backup plan. Unfortunately, most of our nations around the world, they don't have it. And that is an issue. Historically, it started in response to the Arab oil embargo during Arab-Israel war in 1973, when most OPEC countries, they put an embargo on the Western countries on their fuel, and all of a sudden, the fuel price skyrocketed 4 or 5 times, not a percentage, 4 or 5 times. So that's why this energy security term is came. And at that time, 1974, in 18th November, 17 industrialized countries, mainly the Western countries, led by USA, Canada, Australia, and European, France, Germany, UK, and other countries, they organized this this energy security pact. It's called International Energy Agency. Looks like it is international United Nations organization, but it is not. It is a fully private institutional intergovernmental company organization. So initially there was 17 countries. Later they also joined a lot of countries, including Japan and other countries. There are 33 countries, and there are also 6 countries associate members, including China and India and Brazil as well. So, what is the strategy of this pact? It was done in 1974. The main objective was strategic stockpiling of oil, including the US Strategic Petroleum Reserve. I'll come in a second about that. Monitoring and analyzing global energy markets and policies so that they can predict that who is doing what and how can they save their backyard and their back. Energy conservation, so another part of that, and emergency sharing of energy in the event of disruption from one member country to other member country in the need. So at the moment, these reserves includes the crude oil, liquefied petroleum gas, petrol, diesel, aviation fuel for up to 90 days. Up to 90 days. It means 3 months the requirement. That is all fuel reserve at the moment. US strategic reserve at the moment is around 797 million barrels at the cost of market price is $30 billion, which is stored underground in Texas and Louisiana for 43 days. So it is owned by the US Department of Energy. Department, it means the Ministry of Energy. And this is the largest stockpile in the world for oil security. And this is called strategic, US strategic oil reserve. Now, what is the relevance with this with Bangladesh? As you know, Bangladesh is a population of 160 million people. It's a highly densely populated country in the world. And it is also a developing country, and in fact, it's the first developing country, but it is an extremely energy deficient country. So that's why Bangladesh had a policy to harness energy from every possible sources, including municipal solid waste. And that is the relevance is coming the energy security with this. Of course, municipal solid waste energy you harness from there, it will not be replacement of the existing one, but rather it will be complementing with the current need and so on. And I think not only for Bangladesh, anywhere in the world. So, as I said, Bangladesh is unfortunately a very populous country. At the moment, it has 12 city corporations, as all of them are listed here. And this within the city corporation, within the boundary, territorial boundary of that area, almost around 20 million people live altogether. As you can see, I have also listed here all the population list approximate number. In addition to that, there are 4 other city corporation is under construction at this moment. That is also mentioned here. They do not have a lot of population, but still their cities are very fast growing. And in addition to that, Bangladesh also has around 33 municipal corporations. In local language, in Bengali, we call Poroshaba. At present, Bangladesh solid waste, municipal solid waste is around 28 million ton a year. But it is expected to be the number of 50 million ton in 2025. And 2030, it will be more than close to the double. And unfortunately, among the municipal waste collected less than 40%. I'm talking about the entire Bangladesh, including all the major growth. But if you look at, there is a graph, very nice graph. In fact, it was one of the researchers from Russia University of Engineering and Technology, the Habib, and his co-authors is our today's chairman of the session, is Professor Amdadul Haq as well. They published a very nice paper. And this paper, they highlighted how much generation is solid waste is coming from the East Asia, Europe and Central Asia, South Asia, North Asia, and so on. You can see the most of the solid waste is generated, unfortunately, in the developing country, particularly in South Asia and Southeast Asia. And Europe and other countries are very small because they are using very sophisticated systems and the process to recycle, to reuse, and to process this waste very nicely. And the interesting thing is, India alone is around 250 million ton of municipal solid waste is producing. So Bangladesh and India, Bangladesh, although 8 times smaller population compared to India, but still it is aggressively increasing that solid waste. Now, one of the philosophy of the municipal solid waste is that waste management hierarchy. Of course, the most preferred one is the reduction of sources and reuse the material. And if it is, that's why we need to develop a policy so that people can reduce this use of the excessive materials and also as much as they can reuse and this process. So that is the most preferred management of solid waste. And the second one is the recycling and composting. That is the second most preferred methods or the process or the stage. And then, of course, the third one is coming recovery of energy. And the last one, which is nobody prefer it, that is the treatment and disposal. And that is the biggest issue in the all developing countries, including Bangladesh. The reason is most of the solid waste is going to the surroundings and the atmospheric atmosphere, particularly rivers and other places, without treatment, and disposal has virtually no processing at all. So they are absolutely bad thing. So, but that is the things in most developed countries. The treatment is very important, but unfortunately, in developing countries, we are significantly falling behind. Ideally, the municipal solid waste, the management process should be a schematic like this one. As you can see, it is coming with the proper collection system from the location of the solid waste, and then it will be sorted out. And from there, some of the high value stuff, recyclable glass, metals, aluminum should be separated. And then organic matter will go there, and organic matter will be going to other processing. And from there, some of them will go for some of these things will go for compost preparing, some of this fertilizer, and some of them will biogas producing. And biogas later on can be used as a natural gas, or it can be used also power generation for heating and cooling for heating system for the house or so on. So this is the ideal process. But unfortunately, most of the development, including especially Bangladesh, it is far away from this process. So the objective of this paper was the review of municipal waste recycling status in Bangladesh, and then explore some power generation potential from the municipal solid waste based on waste to energy for sustainable economy and development. In 2011, a project was enacted in Bangladesh, the cost of US $180 million, to introduce an integrated municipal waste management system. And the funding, as you can see here, is $120 million from Asian Development Bank, $13 million from Germany, and $13 million from Swedish International Development Agency Authority, and $34 million from Bangladesh. And the target area was this particular integrated waste management system to introduce in 5 city corporations, including the largest city corporation of Bangladesh, that is Dhaka, and also 12 municipalities or Puroshabas and 36 urban centers. But unfortunately, a bureaucratic system and other system, it took very long. And then finally, one of the list or the backbencher from one of the 12 municipalities came forward. They said, okay, we'll go for the pilot project. And that is called Jesor Puroshabha, the place where I was born. And that is the pictorial view of this integrated waste management system in Bangladesh, first introduced in Jesor, the central western city of Bangladesh. And we got myself and also Professor Shombat Chattopadhyay, who is also here today, we got the opportunity in 1999 in December to visit this place for a short time. So this is although it is an integrated system, but it is still not a very sophisticated system. As you can see, the solid waste is coming, is a very primitive way, and then it is being sorted out, and then some of the things, recyclable is separated, and the others, compost solid waste is going for composting, as well as also for generating biogas. And this is the picture where the compost area where they're making, and also the biogas biodigester area, as you can see it here, and also some liquid elements also here. And the third one is in this particular integrated solid waste management system, they actually installed 200 kilowatt biogas powered power plant. And when we were there, we saw 2 units was running. Each unit is a 50 kilo and 50 kilo. At the moment, they said to us that most of the power generated by the biofuel gas, which is generated locally, that actually cover their electricity needs in this area. And then the authors, the principal author of this paper, he collected some of the data in the Dhaka City Corporation, and they're based on face-to-face survey, telephone, and also online survey over the stakeholders. And he compiled a report, analyzed report here. As you can see, this table is shown: plastic, paper, glass, metal, compostable. And you can see, although plastic, paper, and glass, metal, they're good recovery rate, but the compostable waste is virtually zero. And that is the problem, because it is now going unused directly to the rivers, directly to the canals, and also all other places, and they are highly contaminated. So they also looked at some of the heating value content in those materials. As you can see, of course, plastic has the highest number, is 6,700 kilojoule per kilogram, and followed by textiles, and then paper and paper products. There are some other products which has less heating value, although they have some higher energy content. So this is things. On the other hand, in the general nature of the solid waste coming from Dhaka metropolitan city, because there are 2 city corporations, north and south, together their organic compound is 75%, paper is 13%, plastic is a 5% among them. So these are the situation at the moment. And if you look at there, the total the solid waste in the globally, the landfill goes around 46%, recycle 19%, and energy to waste, so waste to energy is 17%, and other is there. And in this table also shows you some different technology, how to process and to get energy and recycle the municipal solid waste, and some of the technology and some of the processes done in incineration, gasification, anaerobic digestion, LPG gas recovery, and pyrolysis, and so on. And if you look at on the right hand side, on the top right hand side, in this figure is also showing you the cost of each of the technology. And you can see the sum of the technology, particularly pyrolysis, is a little bit of expensive zone. But incineration is the most probably affordable, and most probably it will be affordable for developing countries where finance is and also conventional gasification, but it takes a long time. So this is some of the other study, but this study has a lot of oil gas, but it needs to be refined. And at the moment, the work is going on this particular chart, because some are the current data, some based on some prediction data, and you can see some of the money, economic value you can recover from this municipal solid waste. So that is the graph here, as you can see. Incineration capital and operational cost, revenue cost, that is incineration ultimately, and the revenue of the landfill gas, and then also landfill capital and operation cost, and revenue of incineration compost cost. So all these things, as I said, up to 2015, data is based on available data, and based on available data for prediction starting from 2020, because there is no reliable data 2020 and onward here. But this has a lot of assumptions, and these assumptions need to be further looked into very closely to get the real picture of this cost. So to conclude this little work for Bangladesh perspective is that with the growing economy and rapid urbanization, Bangladesh needs urgent integrated municipal solid waste management system. Unfortunately, most of the municipal corporation and the city corporation do not have it. Only Rajshahi and also Chittagong and also some other there at the moment is in this case. Municipal waste collection system is extremely poor in Bangladesh. I did not show you a picture here. It is a very medieval system. That cannot be done. It is a very hazardous and very dangerous for even the people those who are working there. There are professional health and safety. We cannot use that one. Definitely need to be changed. And experience and expertise from Zhejiang integrated the municipal solid waste management system, which is a vital for replication and for sharing across the country. Because that experience and what is good, what is not good, what suits for Bangladesh, what does not suit for Bangladesh, they can actually learn from there and rectify and move on, instead of inventing the wheel again and again for every city. And then later on that wheel may not work. Large city corporations such as Dhaka, Chattogram, Sylhet, Rajshahi, Khulna, Narayanganj have a good potential for biogas generation because they have enough sufficient number or amount of the solid waste. Smaller city does not have. That's why our suggestion is smaller city corporation and municipalities that should be clustered together for each of these integrated systems, so that they have enough solid waste to use for biogas or even for fertilizer composting system generation. Public awareness and incentives are very important for Bangladesh to encourage the people to dispose it the municipal waste in the right collection point, not everywhere or anywhere where they wish. And most important thing is people need to be educated. Awareness need to be created about reusing, recycling, and reducing. These are the 3 R's are very much needed for Bangladesh and also other countries, particularly developing countries where the awareness is very low. And also, it would be better to include about this awareness in the national textbook in the schools, so that our school children become familiar with this and they will practice these things in their future life. And with that note, I thank you all, and I'll be happy to answer any questions if I can. If the serious questions, then I will refer to our principal author and also second author. Thank you.
I want to react. It is an excellent presentation. I just want to know that is there any possibility of foreign direct investments in Bangladesh for solid waste management, maybe from World Bank or Asian Development Bank or those kind of things, if any information is there?
It's a very good question. Generally, private investment very rare. in the waste management, because sometimes there are a lot of things involved with that, particularly in developing countries where the exact economical data to have and to generate an economic model for benefit and return of the investment is difficult. So that's why the private investors are not very local and international, it doesn't matter. They are not very much enthusiastic about investment in this solid waste management system. But the international organization like the Asian Development Bank, they, as you saw, that one of the project in $120 million they invested, that project in pilot project in Bangladesh, and also to replicate in other areas and city corporation in Bangladesh. But World Bank has unfortunately they have a different priority. So it is a little bit harder to get the funding from them directly. So most of these things are coming as they're considered as a low profile for developing countries. So this is why most of the money, little money, is coming only for development aid agencies. But from that, from organization like World Bank, Asian Development Bank, is a very, very meager. Thank you.
Okay, thank you then. And any adoption of good practices from Australia to Bangladesh regarding waste management possibility?
Yes, I think that is the in paper. I must say, in Bangladesh, any project whenever you do, that is the paper is very well, but in reality, it is very slow. But the government has a plan, both in big cities like Dhaka City Corporation. Dhaka City Corporation, there are two: Dhaka North City Corporation, Dhaka South City Corporation, and also like bigger city corporation thereafter, Sylhet, Chittagong, and also Rajshahi. They want to introduce more sophisticated system, like in Australia, the rubbish collection individual house, they will be provided a bin, and from that bin, and that bin will also be three different system. One will be green waste, another one will be recyclable waste, another one will be only the compost waste. So these are the three separate system they want to introduce. But it is still in the planning or in the procurement phase. But in real implementation not happened yet in Bangladesh. But the integrated waste management system, that really needs a lot of investment. And also a lot of, the biggest problem in Bangladesh is their collection system is not good. So that's why more than 75% actually the municipal solid waste is being not coming into collection place. It is actually thrown in the nearby ditch or the canals or the pond or the landfill, something like that. So it is not coming. So until and unless we collect all of them, economical term, it will be very difficult to implement any integrated system that Australia or some developed country they are using it. And remember, when we visited, including yourself, that in Jeshore municipality, they also told us, the people, those who are in charge of that and also working, they told the biggest problem is the collection of material. Sometimes they do not have enough material to produce the biogas. So this is the issue. So collection system need to be improved thereafter the process system. Because if you do not improve the collection system, then definitely this untreated waste is going to the landfill, or it going to the river, or it going to the canal and blocking the system, and also mosquitoes, and also breeding disease, and so on and so on. That is the things. And thereafter, I think step by step we need to do. Thank you.
Thank you very much.
Okay, thank you. Is there any question from the audience? Yes.
One question. Beside the Bangladesh need use about to the biogas in the develop. Bangladesh needs use the another technology for in the country beside of the biogas.
They apart from biogas, I'm sorry, I did not get it.